Hello children, welcome back to physics class. So today's class, let us discuss with the worksheet number 4 numericals of kinematics. Here we start with the first numerical. First one, a body can't have a constant speed and varying velocity. Can't have. So let us consider whether the statement is true or not. For this, let us consider a body which is moving with uniform motion in a circular motion. So whenever a body particle moves with the speed v along the circumference of a circle, then its speed always remains constant. Speed is constant because the body is moving with uniform motion. Whereas if you consider the velocity, let us suppose that if speed of the body is given as some 5 km per hour, everywhere, whether you consider any position 1, 2, 3 or anything else, 1, 2, 3, 4 or 5, any position you consider, speed here is 5 km per hour, here 5, here 5, here 5 as well as here also 5. So at each and every position as the body moves with uniform motion, speed is constant 5 km per hour. Moving to the velocity have two things. One is magnitude as well as direction. As the body moves with uniform motion, the velocity of the body is constant at every position, but at each and every position, the direction of velocity changes. Here, the direction of velocity is given by the tangent drawn at that particular position. If it comes here, tangent drawn at this particular position, something like this. Here this, and here. So every position, the direction of velocity changes. Even if the magnitude changes or the direction changes, we can consider that the velocity changes. But what was asked, a body can't have a constant speed and varying velocity. It's a wrong statement. What is the right statement? A body can have constant speed and varying velocity. So, no doubt, the first statement is wrong. Okay. So, a body can't have acceleration and a constant speed. Can't have an acceleration. Whenever a body is moving with constant speed, then its velocity, what happens to the velocity? So, velocity is, magnitude of velocity is constant. If magnitude of velocity is constant, then acceleration is 0. Everywhere 5 km per hour, 5 km per hour, 5 km. So, if you consider this as V1 and this is V2, acceleration is given as V2 minus V1 by t. This is equals to 5 minus 5 by some time. This is 0 by t is nothing but 0. So, acceleration will be 0. Whenever a body moves with constant speed, acceleration will be 0. So, no acceleration. So, a body can't have acceleration whenever it moves with constant speed, but the direction changes. Direction always at this position, the acceleration due to centrifugal force, its acceleration always acts towards the center. Here also towards the center, towards the center, towards the center. So, whenever a body moves with constant speed in uniform circular motion, body has acceleration and it is indicated in the direction towards the center. So, don't get confused between the acceleration. Okay. So, because velocity is changing, it has also acceleration and acceleration is given as direction of acceleration is acting towards the center of the circle. A body can't have constant velocity and varying speed. This is appropriate because, so body can have constant speed and varying velocity, but the contradictory is not true. That is, a body can't have constant velocity and varying speed is highly impossible. So, this is a Wrong statement. So body can't have a constant velocity. So it's a correct statement. Body can never have a constant velocity and speed varying. Not possible. Body has non-zero speed and zero acceleration. So if some speed is there, then acceleration must be acting on the body. So that is also a wrong statement. So only correct option is option 3. Second one, which of the following changes when a particle is moving with uniform velocity? Whenever a particle moving with uniform velocity, then body is changing its position from time to time. So its position changes with respect to origin. So what can change, children? So position vector changes. Velocity is uniform means speed is also uniform or constant. Velocity itself uniform means constant. So acceleration is 0. So what is changing? Position vector. So one position here, next position, next one, position vector changes. Moving to the next question, that is third one. The correct statement from the following is, a body having zero velocity will not necessarily have zero acceleration. Just now we have considered that. So whenever a body have zero velocity, let us consider a body which has thrown vertically upwards. Whenever a body thrown vertically upwards, at the highest position its velocity is 0. So velocity is 0. But still the body has acceleration, and the acceleration is due to gravity which acts towards the center of the earth. So a body having zero velocity can have an acceleration. So first statement is true. A body having zero velocity will necessarily have zero acceleration. First statement is true. Obviously next will be wrong. Okay, a body having non-uniform velocity will have zero acceleration. So what they are getting, velocity is changing. Non-uniform velocity means velocity is changing. Whenever velocity is changing, some acceleration it must be having. So this must be a wrong statement. Now the last one, a body having uniform speed can have only uniform acceleration. So body having uniform speed. Then speed is uniform but velocity may change. When velocity may change, acceleration also matters. You can take the example of a circular motion. So for the circular motion, uniform speed, body moves with uniform speed. Okay, so magnitude of velocity is constant but the direction of velocity is changing. Okay, so non-uniform velocity and acceleration. So acceleration is always directed towards the center. Different position, different, but towards the center. Okay. So uniform acceleration is not possible. So the only correct option among the following is first option. A body can have zero velocity, will not necessarily have zero acceleration. Example is body projected vertically upwards. At the highest point, velocity is 0, but acceleration is not 0. Moving to the fourth one, choose the wrong statement. Retardation. Retardation means decreasing acceleration, minus a. Is a vector quantity. If acceleration is a vector quantity, retardation is also a vector quantity. So it is opposite to the direct. If acceleration is in the downward direction, retardation will be in the upward direction. Both are opposite to each other. So both have direction. Both are vector quantity. Acceleration due to gravity is a vector quantity because it is directed towards the center of the earth. Average speed is a vector quantity. So no, speed itself is a scalar quantity, has no direction. So option 3, statement 3 is a false statement. Moving to the last one, displacement is a vector quantity. Yes, of course. So displacement is a vector quantity. So what is the only one wrong statement is there, and that is third one, average speed is not a vector quantity, it is a scalar quantity. Moving to the next one. Question number 5, meter per second square. So write this, children, properly. So this, instead of writing like this, let me write it as meter second inverse 2. Okay. So meter second inverse 2 is the unit of acceleration, retardation, whatever it is. Only direction matters, but the value itself is same. Rate change in velocity, the rate of change of velocity itself is taken as acceleration or retardation. So, rate of change of velocity, acceleration, retardation all means the same. So, how much is that rate change in velocity upon time is given as delta V upon T. Change in velocity units is meter per second and time is second. This second bring the above will be getting meter. Second inverse is taken as meter second square. Hence, all the above options are true. So, moving to the next question, that is sixth one. A rubber ball dropped from certain height is an example of. So, what is given, children? Rubber ball is there. The ball is falling down. So, whenever the ball falls down on the surface of the earth, acceleration due to gravity is always taken as uniform and its value is taken as 9.8 meter per second square. So, a rubber ball dropped from certain height is an example of a uniform acceleration. That's it. Accelerating. As and when you move towards the surface of the earth, it accelerates. So, it is accelerating, not retarding. So, it's not uniform retardation. It is only uniform acceleration. Not uniform speed or non-uniform speed. It's all about acceleration. So, the correct option must be option 1, uniform acceleration. Moving to the next one, seventh question. If the velocity of a body does not change, velocity does not change means final velocity, initial velocity, everything is same. So, change in velocity is 0. Then the acceleration is, children, we know that the acceleration is equals to change in velocity upon time. So, change in velocity, as we have said, body does not change. So, change in velocity itself is 0. No change upon time, and this is taken as 0. So, correct option is option 1, that is 0.